It was the first foothold in an uncharted universe, a testament to human endurance, the trailblazer for future explorations of space. For over a decade, it sliced through the boundless expanse, on the cutting edge of technology, a laboratory at the brink of the unknown. And a global village among the stars. 250 miles above the comfort of Earth, the Mir space station soared through space at over 17,000 miles per hour. And even though its glory days are behind it now, Mir orbits still in the firmament of our future. A sparkling emblem of human accomplishment, an enduring monument to the dawn of our life in space.
Knowledge TV Retro, brought to you by Jones International University, the first fully online accredited university. Change your life for the better on your schedule. 8-week classes begin next month. Visit jiu.edu to find out more.
When the last cosmonauts abandoned Mir, this great ship had spent over 4,000 days in space, orbited the planet 76,000 times, and been a home away from home to over 100 cosmonauts and astronauts. An outpost at the edge of the universe, its nearly 30 missions have taught us about our planet, our universe, and ourselves. Leaving behind a legacy of scientific riches and an enduring spirit of international teamwork. But space has not always been a place of cooperation. 30 years before Mir was launched, the Cold War held the world in an icy grip. Space became the ultimate proving ground, a new global arena where superpowers would vie for supremacy. On October 4th, 1957, the Soviets launched Sputnik into orbit, giving them the edge in the propaganda war and instilling fear around the world. Fear that was amplified with the Soviets' announcement of the first intercontinental ballistic missile. Suddenly, the dangers of world domination were no longer just rhetoric. If rockets could launch into space, they could also deliver nuclear weapons to their enemies. Control of space meant control of Earth, and so far, Moscow's lead was incontestable. The space race was on, and in both countries it became a national obsession.
Houston, Tranquility Base here. The Eagle has landed. Roger.
With renewed vigor, the U.S. pulled from behind and became the first to put a man on the moon. Most of the world marveled at this achievement. One of the few countries that didn't televise the event live was the Soviet Union. Since second-place status was equal to failure in their eyes, they abandoned their lunar program. Hoping to regain some of their tarnished prestige, the Soviets quickly switched gears, turning all of their resources towards a space station. Within 2 years, the Salyut space station was ready to launch. It was little more than a tube, roughly 50 feet long and 9 feet in diameter. In 1971, the unmanned Salyut 1 was launched into orbit. After it achieved and sustained a stable orbit, a crew was then launched to dock with the station. But these initial missions were plagued by failure. The first crew was unable to open the hatch. They had no choice but to return home. In June, the Soyuz 11 crew successfully entered and occupied the station for 3 weeks. The Soviets trumpeted the mission with daily national television broadcasts. But the euphoria was short-lived. As their capsule re-entered the atmosphere, a valve malfunctioned. Air was rapidly sucked out of the cabin, turning their spacecraft into a coffin. Resuscitation attempts were futile. These deaths were a severe blow to the nation. What was supposed to be a triumphant return had become a national funeral. Adding to the indignity, the Americans launched the Skylab space station in 1973. Stealing the Soviets' thunder, the American ship gave the world the first glimpse of long-term life without gravity. But the Soviets would recover when the Americans abandoned their sustained presence in space to focus on their shuttle program. And so, with the successful docking of Salyut 3 in 1974, the Soviet space station program, now without competition, was underway. Over the next few years, the Salyut stations were redesigned and updated. The addition of a second docking port meant that the stations could be resupplied and refueled by an unmanned transport craft. Man could now theoretically stay in space indefinitely. The second docking port also allowed the resident crews to receive guests. Over the next 4 years, the Salyut 6 welcomed 8 foreign cosmonauts from satellite nations such as Czechoslovakia and Poland. Records were being set and broken daily. A crew aboard Salyut 7 orbited for 237 days, far surpassing any other mission. The station also welcomed Svetlana Savitskaya, the first woman to live aboard a space station. She would also become the first woman to perform an extravehicular activity, or EVA. But long-term missions were ultimately constrained by the limited space of the Salyut stations. The next generation space station was designed to solve this problem. It was called Mir, which means peace. Mir still had one docking port in the rear. But now the front of the station had a transfer compartment with 5 docking ports. With the addition of new modules, Mir had room to grow. In 1986, just weeks after the Space Shuttle Challenger explosion, Mir's core module was launched into orbit. On March 15th, the first crew boarded the station and got it up and running. They activated life support systems, tested computers, and readied the communications system. The crew then re-entered their spacecraft and flew to the still orbiting Salyut 7 space station. Then, during a live television broadcast, they disconnected an experimental grid and brought it back to Mir. But because of a delay in the launch of the first add-on module, which contained their supplies, the crew was unable to continue their mission. With nothing else to do, they returned to Earth. The first add-on module, called Kvant, would be used for future aft dockings. Over time, 4 more modules would expand Mir into a fully functional habitat. Now, for the first time, man could live in space indefinitely. Spawned in the cooling ashes of the Cold War, Mir was now in place and awaiting a new crew. An exciting new era of scientific discovery was about to dawn. For the pioneers who were lucky enough to visit this outpost, life as they knew it was turned upside down, literally. Mir was roughly the size of a 2-bedroom apartment, but unlike houses on Earth, the residents here could truly take advantage of every inch of space. The multiple docking port, known as the node, was Mir's main intersection. There were 6 different directions to go, and each module was oriented differently. To help normalize the environment, Mir's central module had a carpeted floor and white ceiling. The disorienting surroundings and lack of gravity gave many cosmonauts space sickness during their first few weeks. Cosmonaut and Dr. Valeri Polyakov studied this phenomenon.
The adaptation process takes 3 to 5 days, and then a contemplative period begins, and this psychological adaptation can last up to 1 or 1.5 months.
With 16 sunrises and sunsets a day, cosmonauts also had to deal with an unprecedented sense of time. Establishing a regular routine helped them adapt to their new home. A day aboard Mir began with a wake-up alarm at 8 a.m. Moscow time. Cosmonauts donned their uniforms, then wound their way towards the central module. Mir orbited Earth once every 90 minutes. Every time they passed over one of the communications sites in Russia, they touched base with Mission Control. It was here in the core that cosmonauts would meet for the first communications pass of the day. After the morning's first comm pass, it was time for breakfast. Hot water was added to dehydrated bags of soup. Tins of meat stew were heated in a portable oven. Understandably, the cosmonauts were overjoyed when Progress supply vessels brought them fresh produce and other treats. Eating was just one of the many commonplace tasks that became much more challenging in a gravity-free environment.
And come on into my little room here.
Conducting a tour aboard Mir, astronaut Jerry Lininger answered the universal question, how did Mir's bathroom work?
That's how the cover comes up for the toilet. And the solid waste goes into this container. And the container, when it becomes full, is then sealed off and taken back to Kavam. And for the male or female urination is this tube here is used.
To make the most of their raw materials, everything that could be recycled was. Even the crew's urine was partially distilled to make water, which in turn was used to produce additional oxygen. American astronaut Shannon Lucid said that life on Mir was like living in the back of your pickup with your kids when it's raining and no one can get out. Adding to the claustrophobic feeling of such small quarters was the inescapable hum of thousands of tons of equipment crowding in from every angle. An insidious noise that had to be monitored to keep it within bearable ranges. Combined with the labyrinth of cables and vents connecting the modules, the clutter and confusion were overwhelming. In an emergency situation, trying to hurry through the chaos would become a heart-pounding experience, especially in the dark. Fortunately, such emergency situations were rare. For the most part, life on Mir was filled with long workdays monitoring numerous experiments. At the end of the day, it was time for privacy and relaxation. In space, even the most routine chores, like managing your hair, become cumbersome. Unsecured paper or trash floated free, eventually finding its way into the air filtering system. Tools and personal belongings had to be strapped in place. One of the marvels of microgravity is the unique behavior of liquids. But there is a dangerous underside. As Valeri Polyakov discovered during his Mir 23 mission when he flew headfirst into a giant floating bubble of toxic antifreeze.
Suddenly, out of the darkness, he sees a bubble that he describes as the size of a basketball that's right in front of him. Well, there's no friction in space. There's no way to stop yourself. He starts frog kicking instinctively, but he can't stop, and his face goes whoosh right into this basketball-size globule of antifreeze, which just coats him, just everything, all over his face.
Потом день на четвертый, наверное, вот так вот он, Василий, смотрит, впервые заулыбался.
It was 4 days before Vasily returned to normal. He said, "Fellows, I thought I was dead." He didn't know what was happening to him, but he really got poisoned.
Floating bits of metal or water were other hazards. If they found their way into the operating systems, they could cause electrical short circuits. If they found their way into a cosmonaut's respiratory system, they could cause death. So cosmonauts slept with zipped sleeping bags or with gauze taped across their faces in order to avoid inhaling floating debris. Although the days were long and the rest was needed, sleep aboard Mir was not a serene sleep.
Я назвал этот сон сон матери или кормящей матери.
I would name this sleep mother sleep. She wakes up if her baby makes just a little chirp, no matter how tired she is.
Over time, cosmonauts got used to life inside the craft, but there was no way to fully acclimate to the sensations of being in space. In this unsettling environment, there was endless work to be done, and the work carried its own dangers. American astronaut Jerry Linenger performed the first joint U.S.-Soviet spacewalk in 1997.
You feel like you're falling the entire time. It feels like the space station itself is falling. To the point of free-falling parachuting, it gives you that sensation pretty much the whole time. On the end of the Strela arm, it was very flimsy feeling. It felt like you were a fish on the end of a very flimsy fishing pole, getting whipped back and forth.
Джерри, помаши рукой.
Левой, левой.
Левой рукой помаши, Джерри. Вот, едем отлично.
And when it gets dark, that instant you are basically blind and falling. Even in the dark, it feels like you're falling for some reason.
Working under these conditions, Mir cosmonauts performed numerous extravehicular activities, or EVAs, to build and maintain the ever-expanding station. But many of the EVAs proved difficult. On the second main mission to Mir in 1987, cosmonaut Alexander Leviathan experienced the spacewalker's worst nightmare. Minutes into the EVA, Leviathan believed that his spacesuit wasn't behaving properly. He felt the pressure dropping. Panic set in as he feared something was terribly wrong. Just a few seconds in space without life support would mean certain death. His commander realized Leviathan hadn't turned on one of the spacesuit's controls and quickly flipped the switch for him. Nevertheless, this incident severely shook Leviathan, and within days his cardiac telemetry began showing irregularities. This condition would lead to his replacement. As frightening as Leviathan's experience had been, he was at least properly trained. Not all crews were prepared for what they'd encounter. As the Soyuz spacecraft carrying the 6th main mission crew was approaching Mir in February 1990, Mission Control was shocked by the sight of heat shields flapping around the vessel. If the thermal blankets weren't repaired, there was real danger that the capsule might burn up when the crew later tried to return to Earth. Cosmonauts would have to make an unplanned EVA to repair the heat shields, despite having never received special training. Down below, scientists formulated a plan for reattaching the blankets. The spacewalk started badly. When they opened the hatch while there was still air remaining in the airlock, it shot outward with tremendous force. Their repair work didn't fare much better. Their spacesuits gave them only 6 hours in space, but it was taking them nearly that long to reattach the thermal cover. As every minute passed, precious air and heat were running out. As they finally completed their task, they raced back to the airlock, leaving their tools behind. It was then that they discovered the hatch wouldn't close. They were now half an hour past their suit's rated use. Luckily, the backup airlock worked. With their oxygen supply dangerously low, they were able to re-enter the safety of the station. Engineers on the ground attempted to find solutions, but subsequent repair efforts were only partially successful. For years to come, the hatch would be held closed by a pair of ordinary C-clamps. Throughout the period that Mir was operational, its residents overcame numerous challenges thrown at them by their unique environment. But whether man is truly suited to life in space remained an unanswered question.
Knowledge TV Retro, brought to you by Jones International University, the first fully online accredited university. Change your life for the better on your schedule. 8-week classes begin next month. Visit jiu.edu to find out more.
A giant laboratory in orbit, Mir set out to not only prove that man could live long-term in space, but to lay the groundwork for deeper exploration of the universe. If cosmonauts ever plan to visit distant planets, they need to grow food aboard their spacecraft. And they need to design and manufacture materials that would hold up to the ravages of space travel. Experiments in the growth of crystals in a microgravity environment explored the possibility of developing materials superior to those which could be produced on Earth. Cosmonauts also needed to find out what kind of creatures could thrive in this new world. Mir gave man the opportunity to see how common things behaved in an uncommon environment. There was also important work performed in Earth sciences. From its perch 250 miles above the planet, Mir was the ideal platform for environmental studies by a huge array of instruments. Sophisticated telescopes also helped Mir turn its gaze toward the universe. In the 7 main science programs that made up the core of Mir's research, over 19,000 experiments were conducted. But the biggest experiment of all lasted the entire flight, studying the adaptability of human beings to life in space. Of key interest was the effect of weightlessness on the human body.
You are relaxed, comfortable, somehow you feel nothing. But it's dangerous because all your muscles atrophy.
To explore this phenomenon, the 14th International Mission arrived in August 1988 with an important new medical experiment, Dr. Valeri Polyakov. In addition to checking the health of the long-duration flight crews, Dr. Polyakov would use his own body as a living laboratory. Before his flight, he had undergone an operation to remove a sample of his bone marrow. He would remain on Mir with this crew and the next. On his return to Earth, another sample of his bone marrow would be removed. It was hoped the resulting comparison might provide insight into the physiological changes caused by long-term weightlessness. Dr. Polyakov also studied the psychological stresses of spaceflight. The Soviets were particularly interested in the crew's mental health.
Если психологически правильно подобран экипаж,
If a crew is psychologically compatible, the flight goes better, and everyone returns with fond memories.
это легко проследить потом на Земле.
Once the cosmonauts have returned to Earth, it's easy to see if they got along. Sometimes they come back and don't even want to see one another.
Polyakov had the chance to observe a crew completing a record 365-day stay in space. Each new duration record was hailed as another great achievement in Soviet space medicine. But the cosmonauts had quietly been paying a price. Upon their return, most cosmonauts told a similar story. The first 3 months were filled with glorious exhilaration. But shortly thereafter, things began to change. Each day grew increasingly more difficult. 6 months into their stay, most cosmonauts were plagued by chronic fatigue, irritability, and stress.
I flew on 4 long-term and short-term missions, and I can tell you that the most important thing is to respect your crewmates. If anyone thinks they are better than anyone else, that is a big disaster.
Any stay longer than 6 months was psychologically intolerable. Yet the cosmonauts were being forced to work far beyond that time frame. In addition to these observations, Dr. Polyakov's bone marrow would tell of yet another cost being exacted on the cosmonauts. Extended time at 0 Gs caused conditions similar to those found in patients with osteoporosis. But bone density loss occurred at a rate 10 times faster than that on Earth. On his second mission to Mir, Dr. Polyakov would stay in space for a record 437 days, studying ways in which physical and mental decline could be mitigated.
А эти проблемы, они, в общем-то, классические. Это снижение работоспособности, это снижение
These problems are classical. Lowered work ability, decreased motor ability, atrophy of heart muscles, loss of bone calcium, probability of sudden bone fractures during overexertion and before landing, and many other blood problems, including changes in the biochemical components.
Soviet cosmonauts engaged in a continuous regimen of exercise and testing to combat deterioration. But it would only restore partial strength. These findings caused the Soviets to change how they scheduled their missions. Later flights to Mir would last from 120 to 180 days and no more. These shorter stays meant that the cosmonauts would be more efficient in their work and research while on the station, and return to Earth with less physiological damage. Relaxation became recognized as an important activity, and having fun and unwinding was encouraged as a way of reducing psychological pressures. But much of the stress of life in space was closely tied to the experience itself. Being on Mir was like being on no place on Earth. Even though it seemed to float as an isolated and pristine outpost for science, Mir was always tethered to the world turning beneath and the changes which were rapidly unfolding below. This was never more obvious than during the collapse of the Soviet Empire in 1991. As their country on Earth crumbled, cosmonauts were left to ponder their fate in space. With sparring factions dividing the spoils, no one was sure who would accept the responsibility of Mir and its crew. Those within the program began a series of desperate efforts to keep Mir alive within a space program that was dying. The up-and-coming Buran space shuttle was abandoned, and its empty shell became a Gorky Park tourist attraction. Mir itself became a motel, available for visits by the highest bidder. Mission 8 in 1991 represented the first entirely commercial flight to Mir. On board was a Japanese journalist who had broadcast live from the station for 7 days. Mir was reduced to a location for PR and commercials. The cosmonauts' schedules became increasingly crowded as they hawked products for companies on Earth. Of even greater concern, Russia no longer seemed committed to its space program. Without state financing and support, the once invincible spacecraft began to show its age. Mir's future seemed as empty as the void through which it sailed. Though it soared free of Earth, Mir couldn't escape the gravity that world politics imposed on it. The Soviet government had never scrimped when it came to the crown jewel of their space program. Every year, they found the hundreds of millions needed to maintain and upgrade the aging ship. But in 1991, with the Soviet Union fractured into individual countries, the future of Mir seemed bleak. The split-up of the Soviet Union had divided the state's space facilities among bickering neighbors. The foremost launch facility was now controlled by Kazakhstan. The company which manufactured the computerized docking systems was now located in Ukraine. Getting supplies and parts for Mir became a logistical and economic nightmare. Russia took over the space program but couldn't manage its hefty bill. They weren't the only ones with a floundering space program. NASA was having an increasingly difficult time coaxing funds from Congress. Despite an active shuttle program, plans for a space station were lagging. Nearly a decade and billions of dollars after Ronald Reagan gave NASA's International Space Station his blessing, not a single component had yet been launched. The time was ripe for the former space rivals to join forces. Anxious to keep Russian rocket scientists employed and their military secrets out of renegade hands, a deal was forged between Washington and Moscow in 1994. The U.S. would pay some $400 million in rent, and the Russians agreed to extend the station's life to include the training of astronauts. The idea of working together had great scientific and diplomatic potential, but an aging spacecraft would test the mettle of everyone involved. In advance of the first cooperative mission, 2 additional modules were set to join Mir. Named Spector and Priroda, they would accommodate the influx of international science planned for the visiting astronauts. In March 1995, Norman Thagard became the first American to board the Russian space station. But when the module carrying all of his experiments ran into delays on the ground, Thagard was left with little to do for 3 frustrating months. When the space shuttle Atlantis completed the historic first docking of an American shuttle with the Russian space station, the shuttle delivered Mir's new replacement crew and brought Thagard back to Earth. The second NASA mission to Mir was a huge public relations coup. Shannon Lucid's ability to integrate with the Russian crew touched a popular chord. There seemed to be hope for Russian-American cooperation. The addition of the Spektor and Priroda modules had significantly upgraded Mir. Along with research equipment for the NASA astronauts, they contained equipment to monitor atmospheric gases and study the Earth. And Spektor carried new solar arrays to boost Mir's lagging power supply. But these new modules complicated an already extremely complex station. And while the addition brought benefits, it also offered added opportunity for failure. The last thing Mir needed was more problems. A decade in space and recent years of limited maintenance had taken its toll. A leaky cooling system added to pervasive moisture problems. Condensation was a constant source of corrosion. Cosmonauts now spent as much as 75% of their time doing repairs. All hands were needed just to keep Mir functioning. NASA had no idea how dire the situation had become. But those on board were about to find out. In 1997, the crew of Commander Valeri Polyakov and engineer Alexander Lazutkin joined Mir. Astronaut Jerry Linenger, already on board, would be with them for the next 3 months. With 2 crews aboard, the air inside Mir was getting thin. It was decided they needed to pump more oxygen into the station. Lazutkin was familiar with the routine procedure in which a solid fuel generator is used to increase the oxygen flow, but he couldn't be prepared for what would happen next.
Помимо характерного звука, такого шипения, выходящего кислорода, появилось потрескивание.
Besides the hissing noise of the oxygen, I heard a crackling sound.
Смотрю вот на этот ТГК, а он сверху закрыт еще мешочком, таким специальным фильтром.
I turned back and looked at this filter, which is covered with a special fireproof material.
Искры, которые появляются на этой ткани, и сжигают ее.
I was watching sparks coming from it. I was shocked by the sight of an erupting volcano.
The fire was basically in this region here, with the flame shooting across this way, and I was passing the fire extinguisher. At that time, the other Soyuz was on the other side where Progress is now docked. So as you can see, it would have been very difficult to get through the flame itself to get to to one of the rescue vehicles.
Dense smoke had filled the station. Once the fire was out, the cosmonauts were able to survey the damage. The fire and its aftermath raised a number of troubling concerns, foremost of which was the lack of communication between the Russians and Americans. The NASA support team in Russia was not informed of the fire until the following day, and even then, Russian officials played down the grave nature of the accident. On March 4th, 1997, just 2 weeks after the fire, yet another crisis would befall the Mir crew. Supply crafts called Progress regularly visited the station. These dockings had always been guided by an automated system. But Russian Mission Control wanted to use a much more economical manual procedure.
Basically what happened is, as he's sitting there watching the camera aboard the incoming cargo ship, it's blank. It's blank the whole time. He never gets a picture. All he knows is that he's got a huge spaceship, what does it weigh, 20 tons, bearing down on him that has been sent flying at him. He can't see it, much less catch it. He can't even see it. And when it's supposed to be here, they don't know if it's going to hit him and kill him or if it's going to go whizzing by. And of course, as those seconds tick away, something approaching panic builds up on the station. The cosmonauts sound the alarm. Everybody starts scurrying for the Soyuz to escape. And then at the last moment, it goes whizzing right by.
Incredibly, NASA remained unaware of risks involved in this manual docking attempt. Linenger didn't inform his ground crew of the near miss because he assumed they knew about the incident. In reality, they had never been told. Russian ground control suspected that the radar system in use might have interfered with the video signal, and so a fateful decision was made. On the next docking attempt in 3 months, they would turn off the radar. With American astronaut Michael Foale now aboard, Sibilyov would once again attempt a manual docking with an incoming Progress craft. Without the radar, he had no data regarding the speed and proximity of the Progress craft. His only guide was the cloudy video taken of Mir from Progress. It was nearly impossible to make out. Lazutkin would have to provide information using a handheld radar gun. But the approaching supply craft was hidden from view by a solar panel until it was too late.
At that moment, chaos breaks out on the station. The first thing that happens is that the decompression alarm comes on the main computer. Lights going off everywhere.
The collision was so loud and so powerful that the whole station was shaking. We knew we had been hit.
Sibilyov floats down to a window that's essentially at his feet and looks down, and he sees the Progress ship lodged against the Spectre module. I mean, it's hit hard. It has damage. The station has damage. They're losing air.
As their life-sustaining atmosphere drained into the vacuum of space, the crew was in danger of losing consciousness. If they couldn't seal off the damaged module or abandon Mir, they might all die. As quickly as possible, they needed to close the hatch leading to Spectre, but a tangle of power lines and tubing stood in their way. They disconnected whatever cables they could, then, with the pressure growing dangerously low, cut through the others with a kitchen knife.
First, I tried to close it, but it wouldn't close. I asked Michael to help, but then I realized that the escaping air was holding the hatch open.
He had the idea essentially that saved the station. He remembered that when each of the modules came up on its own and was docked to Mir, that they each came with a lid.
I remember that we have a special coverings, and I grabbed one.
The oxygen gradient that had worked against them before works for them now. And the moment they put it up there, oxygen sucks it right in, decompression alarm goes off, and for the moment they're okay.
But the situation aboard Mir continued to deteriorate. Its solar panels had been knocked out of alignment with the sun. Without this crucial source of power, the batteries drained, and most of the systems aboard had to be shut down. Months later, an EVA restored about 80% of Mir's power, but Spectre was damaged beyond repair. 2 more Americans joined Mir after the near catastrophes, but doubts lingered at NASA. With these disasters fresh in their minds and their commitment to the Russians fulfilled, the Americans ended their Mir programs and returned their focus to the International Space Station. Without American funding, it seemed that the Russians would be unable to keep Mir in space, and so an era was coming to an end. As the 27th main Mir crew departed in August 1999, they left the station uninhabited for the first time in 9 years. Life support systems were shut down. Power was turned off. The once bustling frontier settlement became a ghost town. Mir was left to circle the planet indefinitely while those below decided its fate. Some in Russia fought to keep this last great vestige of the Soviet space program alive, but sentiment was no remedy to the ravages of time. Serving nearly 10 years past its expected lifespan, the old soldier's tour of duty had finally come to an end. During its lifetime, Mir made the void at the edge of our universe an inhabitable domain. A trailblazer in the exploration of space, it launched a new era of discovery and left behind a bounty of scientific riches. Wherever we voyage next, to new colonies in space, to distant planets, or beyond, we must salute those who forged the path. Thousands of engineers, 100 bold travelers, and one tough old space station called Mir.
Knowledge TV Retro, brought to you by Jones International University, the first fully online accredited university. Change your life for the better on your schedule. 8-week classes begin next month. Visit jiu.edu to find out more.